Now we see the next example. F of x equal to e to the power x and g of x equal to e to the power minus x in the interval AB. Second example. F of x equal to e to the power x and g of x equal to e to the power minus x in the interval AB. In the closed interval AB, a equal to a and b equal to b. Now here f of x and g of x, it is the exponential function, it is continuous on the closed interval AB and they are differentiable on the open interval AB. These functions are continuous on closed interval AB because these are the exponential functions and differentiable on the open interval AB. Again I find g of a, g of b. G of a equal to e to the power minus a and g of b equal to e to the power minus b. Therefore you observe that g of a is not equal to g of b. G of a is not equal to g of b. That is the third condition of the Cauchy-Mingel theorem is satisfied. Hence all the three conditions of the Cauchy-Mingel theorem are satisfied. Hence all the three conditions of Cauchy-Mingel theorem are satisfied. Therefore, according to Cauchy-Mingel theorem, there exists a point C which belongs to the open interval AB such that implies there exists a point C belongs to open interval AB such that f dash of C f of b minus f of a divided by g of b minus g of a equal to f dash of c divided by g dash of c. Now put the values and find the derivative of f. You will get f dash of c and g dash of c. F of b, that is e to the power b minus f of a e to the power a divided by g of b e to the power minus b minus g of a e to the power minus a equal to f dash of c. Now first the derivative of f of x, f dash of x, you will get derivative of e to the power x, e to the power x and derivative of g of x equal to derivative of e to the power minus x, e to the power minus x, again derivative of minus x minus 1. Therefore, minus e to the power minus x. Therefore, I find f dash of c. Put here x equal to c, e to the power c divided by g dash of c. Put here x equal to c. Therefore, minus e to the power minus c. Now simplifying this, e to the power minus b, take to denominator, e to the power minus a, take this denominator, therefore we have e to the power b minus e to the power a divided by 1 upon e to the power b minus 1 upon e to the power a equal to, here e to the power c, take this e to the power minus c in the numerator, or we can write this as e to the power c minus e to the power c into e to the power c. Therefore, we get addition of indices e to the power twice c. Now here take the LCM as e to the power e b into e to the power e. Therefore, e to the power b minus e to the power a divided by, here the LCM will get e to the power b into e to the power e. Then by cross multiply 1 into e to the power e to the power e minus 1 into e to the power b e to the power b equal to minus e to the power twice c. Addition of this index c plus c twice c. Then we get this as here e to the power e minus e to the power b. Here e to the power b minus e to the power a. If we take minus in common, then this will get cancelled. E to the power b minus e to the power a divided by minus e to the power a minus e to the power. If we take minus and common, here we get e to the power b minus e to the power a. Now 1 upon this we will get in the, it is in the numerator e to the power b into e to the power a. Now this get cancelled, same, equal to minus e to the power twice c. Again cancelling minus sign from both sides, we have addition of indices, we get e to the power a plus b equal to e to the power twice c. Now base is same, e, therefore equating the indices, we have a plus b equal to twice c. A plus b equal to twice c. Therefore c equal to a plus b divided by 2. Now the open interval is ab. Therefore this value lies between the open interval ab because a plus b divided by 2, it is greater than a and less than b. Therefore it belongs to open interval ab. Hence value of c exists. Therefore Quansi mean value theorem is verified. Then we see the next example, f of x equal to this 2x square plus 3x plus 1 and g of x equal to this. Third example, here f of x and g of x are continuous on the closed interval 0, 3 and differentiable on open interval 0, t, because this is polynomial and we know that polynomial functions are always continuous. Since these are polynomials, the next condition is g of a equal to g of 3, that is x equal to 0, 0 square minus 3 into 0 plus 2, therefore 2, and g of b, that is g of 3, g of 3, that is 3 square minus 3 into 3 plus 2, therefore 9 minus 6 plus 2. of 3 equal to 3 square minus 3 into 3 plus 2. 6, 9 minus 6, 3. 9 minus 6, 2, 2 plus 4, 4. 3, 5. The formula is u of x equal to x square minus 3x plus 2. Interval is 0, 3. Then you get 3 into 3, 9. Therefore 9 will cancel, we get 2. Therefore the value of u of a equal to 2, value of u of b equal to 2. Therefore the third condition, u of a is not equal to u of b is not satisfied. Hence u of a is not equal to u of b is not satisfied. Hence Cauchy's mean value theorem is not applicable for these functions. I have tried to solve one example as a homework. F of x equal to cos x and u of x equal to sin x. In the interval 0, 5 by 2. Now for this case you will observe that f of x and u of x are continuous in the closed interval 0, 5 by 2. Also these are differentiable in the open interval 0, 5 by 2. And what you get? F of g of a, that is g of 0 equal to sin 0, 0. G of b equal to g of pi by 2 equal to sin pi by 2 equal to 1. Therefore these are not equal. Therefore g of a not equal to g of b. Therefore all the three conditions of the Cauchy's mean value theorem are satisfied. Therefore according to Cauchy's mean value theorem, we have f of b minus f of a divided by g of b minus g of a equal to f dash of c divided by g dash of c. F of b means cos of b. B means this value a equal to 0, cos pi by 2 minus f of a cos of 0, g of b sin pi by 2 minus g of a sin 0, f dash of c, derivative of cos of x minus sin x minus sin c divided by g dash of c, derivative of sin x cos x, therefore cos of c. You know sin 0 is 0, cos 0 is 1, cos pi by 2 0, sin pi by 2 1. Therefore we get 0 minus 1 divided by 1 minus 0 equal to minus tan of c. Therefore tan c equal to this minus minus plus. Now we know that tan of pi by 4 equal to 1. Therefore we get c equal to pi by 4. Now observe that this value of c belongs to open interval 0 pi by 4. That is the value of c exists. Therefore the Cauchy's mean value theorem is verified for the functions cos of x and sin of x in the interval 0 pi by 2. So try to solve. Start here.